This is Algebra 1, Semester 2. It's the unit on quadratics, unit number 3, and it's a lesson on combining linear, exponential, and quadratic practice. It's lesson number 11. It's on creatormath.com. It's under the Algebra tab. You might have to type in creatormath.weebly.com to get to it and search for it in Google. Copy the following problems into your composition book on the correct pages according to the table of contents with the notes for those pages from creatormath.com. I might just model that for you very quickly. Remember, you're filling out your comp book as we go through these lessons. Let's see, this is a geometry lesson. Let's go back. Here's what creatormath.weebly.com looks like. Let's go to algebra, pass by the vocab stuff, and get to semester 2, table of contents. Scroll down. This is exponents and polynomials. This is modeling 2 variable data and quadratics. And we are all the way down here in number 11. Right? Number 11 we're in. Number 11 says comparing linear, exponential, and quadratic functions. This goes on page 75, 76 of your comp book. And these pages may change over time, you guys. So if you're watching this sometime later, take the pages off the table of contents, not this video. But right here says notes. You'll click that. Open up the notes. This is what goes on those pages. It takes a second to load, and this is the explanation of what we're going to be dealing with. So you'll start here, things like quadratics. It's talking about lines and linear functions. It's talking about parabolas and quadratics. And it's talking about exponential functions. There they all are. And you're going to use these to solve these problems. Slash, you're going to use this information to deepen your understanding. Vocab, exponential, quadratic, and linear. And that's it. So, and it may have the pages on here, but again, please check the current table of contents to make sure you have the right pages. Some of these are starting to get old. I did them on the board. I don't know how long ago, but that's how you have the notes. Go back. You'll also see the problems, and you'll also see the video link here once it's done. It'll say video solution right there. We can click problems to see if you want to print out a set of problems. I wouldn't. I would just copy these into my comp book and watch the video on how to do them. But you can have a PDF of it if you want to. All right. So, and then right here where it says video solutions, see how this link's active? This link will be active once we're done with this video. All right, based on that, let's see what we got. So given the following graph, is it linear, quadratic, or exponential? All right, morning, Brian. Okay, so, and you made it, appreciate that. Look at your preloads, Brian, while I'm doing this, okay? So this lesson is on comparing different types of graphs, and it's done at a very high level. We're not going to go too far into it. We're going to deal with just the basics. And students often miss some of this stuff, even though sometimes us teachers think certain things are obvious, and they're just not, all right? The word linear means line, right? So if the graph is a line, guess what? It's a linear graph. And I know that seems simple when I say it, but it's just not always that obvious, all right? Quadratic gets a little more complicated. That's anything y equal to x squared with the power 2, and that's the shape of a parabola. And I'm drawing a really bad parabola, but it looks like that, right? Spelled parabola, but pronounced parabola. And then exponential is, like the spread of a virus. It starts out, goes to 2 people, each of those get 2 more people sick each, and all of a sudden the entire world is sick, right? That's an exponential curve. So 3 graphs, and all they're going to do is run through examples of them and ask us which is which. What do you think this is? Is it a line? Is it an exponential function? Or is it a parabola, which is a quadratic? So, and remember, parabola is spelled parabola. Parabola. But don't say it that way. Your teacher next year will be like, who taught you this? And you just spell it parabola. You say it parabola, right? That's a parabola, and it's got a vertex and other pieces that we've been looking at as part of the other lessons. And that's from a quadratic. A quadratic, just again, is anything with an x to the power 2, right? So you see different formats. You'll see a generic format like f of x equals x squared. This is a function format with f of x. This is using y because we have an x-axis and a y-axis. This is an x-axis and an input, right? This becomes the input that goes in here, and then whatever this thing equals becomes the output. All those things you know about functions. All right, let's keep going on the point of this lesson. I bet they're going to give us the next one. Sure enough. exponential. So exponential, really starts out sort of slow. And remember, at the beginning of the virus, it doesn't look like that many people have it, right? Then you pass through some point. These curves always pass through the y-axis at 1. The exponential curves do. And then all of a sudden, so many people start getting sick that this thing just goes up to the moon, right? Now everybody's sick. That's called an exponential graph or an exponential curve. And we now, unfortunately, understand a lot about exponential curves we might not have understood before, just because we've lived through this understanding of how a virus spreads. Given the following function, is it linear, quadratic, or exponential? By the way, they want us to go to Desmos and type this in. So let's go ahead and model that quickly just so you can see what that looks like. Okay, let's see if I can find it first. Desmos, right? So this is the address, desmos.com. You click calculate. It's got a graph. It asks for this thing to be put in. What are they asking for right here? Look how simple. F of x equals x. You can type this two ways. You can type y equals x. And guess what it forms? That's a straight line, right? So I already know it's linear. But just to note, this f of x is function notation. And Desmos is so cool, it'll take either notation. So let's clear this out and go to ABCs and say f parentheses x parentheses. Once we get the function notation, boom. So students are often, hit with this. Always we hit you with new things in math, right? We taught you that in grade school, if you wanted to write 3 times 4, you would use an x, right, for times. Then you got to middle school and we're like, oh, by the way, you can't use an x anymore for times because x is a variable. And you're like, what? When did this happen, right? So we'd spend all this time teaching you that y equals x is how you graph. Then out of nowhere we go, by the way, there's function notation, f of x equals x. So we're constantly like going over the exact same topics with you. We're just adding to the depth of what you hopefully know and understand about it, right? So fortunately, Desmos will graph either function notation or just standard graphing y equals x formation. And this is a line. Let's see the next. So let's go ahead and use Desmos just like they're telling us to. Y equals x squared, or f of x equals x squared. Right here, you just do this key, boom. Oh, a parabola, which is a quadratic, by the way, and we know it's a quadratic graph. And probably I should have put parabola for some of these because they're interchangeable. You could say it's the graph of a quadratic, and the actual graph name of a quadratic is a parabola. All right, so I might wish that I had put parabola also on this, parabola. Let's put that in. That's the way I have to remember how to spell it, right? So put parabola in there. Let's see the next graph. All right, now check this out. This one they want us to graph is 2 to the x. So now it's not x to the 2. It's a 2, and it's a caret x. And why do I not know how to do this? 2 squared, back, delete, x. Oh, took me a second, but I got it. Notice it passes right through the y-axis at 1. And even if you start to manipulate these numbers, this always occurs this way. It's a cool feature of the exponential function. So this one's exponential, okay? It's the virus. Just think of virus. Yeah, I should have put in parentheses here, virus, the virus curve. Because even if you understand it from that perspective, it's a big help for your brain to understand what we're talking about. And obviously we have, well, not obviously, but we use graphs to illustrate physical things that happen in life, right? A straight line is applicable in some situations. A parabola may be less applicable in life, but the exponential curve is very applicable in the spread of a virus. So what is this? What is the following graph? You guys, it's a line. Linear means line. And so sometimes math can be so hard, and sometimes it can be so easy. So given the following, it's a quadratic. Again, I should probably say parabola in parentheses. So this one, they don't go into too much detail, but this is the reverse. Like if an exponential is moving this way and up, I'll draw it a little bit better right here and up. This is one form. We can also have something that decreases in an exponential fashion, right? Or the reverse of an exponential fashion. It decreases very quickly at first and then slows down but continues to decrease over time. And incidentally, these graphs here never reach zero, right? They continue along the x-axis in both these directions but never ever reach it. A very cool concept. Exponential and maybe virus in here. Maybe I'm modifying my lesson as I go, or the problems for this lesson as I go. And I'll change it by the time you guys get to it, okay? So you won't have to worry about it. Given the following function, is it linear, quadratic, or exponential? Use Desmos.com. So look at this. It's 1/3 x plus 3. Well, let's just take their advice. They're telling us to use the technology. Let's just type it in. 1 divided by 3. There's 1/3. Go over to the right. Say x. So it's a line. They have a plus 3. Right here, I'm looking right here on my paper. Plus 3. So it's a line, it just moves up to the y-intercepts of 3. And if you remember how to graph, y equals mx plus b, right? This is the m, the slope, so it rises 1 and runs 3, and it crosses through the y-axis at plus 3. And you start here and you go rise 1, 1, 2, 3. Rise 1, run 3, and there would be another point. Rise, run. And this is back to when you used to graph and plot all the points. Now you just type it into Desmos. Thank goodness. Linear. That's a line. Given the following function, is it quadratic or exponential? So once I have an x squared, I know it's quadratic. It's a parabola, you guys. Parabola. Right? And I would just say, if I wasn't sure, because I might not be if I'm seeing this for the first time, let my brain see it in terms of Desmos here. Let's do x caret squared. So x squared. I got my parabola. Plus 8x plus 8x plus 15 plus 15. And there it goes. So it's moving around the base function. The base function is a parabola right here with the vertex at 0. Once we start doing this 8x, it either expands it or shrinks it. And once we do plus 15, it starts to move around, right? And once we factor this, then we can see why it has roots here, etc. And that's in some of the other lessons for this unit. How about this one? Well, if you haven't figured out already, any number raised to a power x is an exponential function. That is its definition. We're just going to go ahead and prove it here. We're going to say 3. Let's get rid of this. And notice once I put in the first function, I'm just, retyping it each time. I mean, I'm modifying. I'm not retyping it. I'm modifying it each time. 3 to the 2 power. I'm not quite sure how to do this. There's a better way, probably. And I'm going to put a parentheses around this minus x, just to make sure it's all contained as a power. I don't want it to get separated, and I probably don't need to, but here's my curve coming down, exponential in reverse, right? It's declining in a reverse exponential fashion, which means it declines super fast at first and then slows down and slows down. Rather, the opposite is, once a virus spreads, it spreads slow and then increases. And the cool thing about Desmos, if you don't know this, you could come right here and say y equals 3 to the, let's do the power x here. And it'll put in the other curve. So here's y equals 3 to the power positive x, and here's y, or f of x. Either one's, they're equivalent, they graph the same way, or f of x is equal to 3 to the power negative x, and notice how they change. So you can just keep typing in functions, and it'll graph them all for you at the same time, and your brain can go, oh, this is the blue one, see the blue one, this is the red one, and your brain can start to figure out how things change as you change any number of factors in the actual function. All right, given the following function, is it linear or exponential? So this one's interesting. They've already broken it into 2 binomials. Normally we multiply the binomials first. Let's just nuke this. Let's back this up. Let's just try to type in what they've got. X plus 3. X plus 3, parentheses. And let's multiply it by x plus 5. X plus 5 parentheses, right? Look at that. It still graphs the parabola, even it's two binomials multiplied by each other. Now, you might have learned if I have two binomials, let's do FOIL. First, outside, inside, and last. First is x squared. Outside is plus 5x. Inside is plus 3x. And last is 3 times 5 is plus 15. Okay, you can still see that barely. And combine like terms, 8x plus 15, x squared plus. So notice, if we multiply the binomials, we get x squared plus 8x plus 15. Well, let's do another one, a blue one, and say y equals, I'm only saying y equals because it's easier to type than f of x. Y equals x squared plus 8x, x squared plus 8x plus 15, plus 15. Look at that. The green parabola is right on top of the red parabola because these are equivalent. And that makes sense to us. If you had 3 times 2 and you had 6, your brain should know that those two things are equivalent, right? So this is an equivalent graph. This is an equivalent quadratic here and here. They're just in different forms. This one's been factored, so we can see the roots. This one has not been factored, but it's been multiplied. All right. So you make sure you're in the right place. You're going to creatormath.com under the Algebra tab. You're in Semester 2. You're in the Quadratics unit, and you're in the 11th lesson called Combining Linear, Exponential, and Quadratic Practice. And what it's really doing, I think this actually should be, honestly, I think this should be comparing. I'll look at that too. You're comparing those graphs. So if not, I might change it anyway, but it might be a mistake, okay? Hope that helps.